Okay, so functions, probably one of my favourite topics because it actually lends itself to so many skills. So here are the functions f and g, and f of x is defined by this. So this is saying the function of x is defined by a half lots of x plus 4. And then here we have the function of g is defined by g of x. Okay, imagine this x. You can imagine this as, in fact, you can say the function of square equals a half lots of square plus 4. That's essentially what we're doing here. And the g of square equals 2 lots of the square divided by the square plus 1. So for the first question, nice and simple, it says, work out the value of f6. So this is saying f6 means wherever there is an x, I'm going to substitute in 6. And whenever I do substitution, I'm going to use brackets. So half lots of x. Now our x is now 6 plus 4. A half lots of 6 is 3. 3 plus 4 is 7. Okay, part B says find f of g of minus 3. So this is saying the function of g of minus 3. Now mathematicians are slightly lazy and a bit innovative. This is literally saying f of g of minus 3. So step 1, I'm going to find g of minus 3. So g of minus 3 is g of minus 3 equals 2 lots of minus 3 over minus 3 plus 1. 2 times minus 3 is negative 6 over negative 3 plus 1 is negative 2. Negative 6 divided by negative 2 is 3. So g of minus 3 equals 3. Now I'm going to go back to my original f of g of minus 3. Well, we just worked out that g of minus 3 is actually 3. So now I'm going to say this is the same as f of 3. So f of 3, we know f is a half lots of x, which is now our 3, plus 4. A half times 3 is 1.5, plus 4 is 5.5. Some of us might like to write that as 11 over 2. Either or are correct and they are completely equivalent. So, part C says g of a equals negative 2. So I'm just going to write this down. G of a is then 2 lots of a over a plus 1. Okay? So I can simplify this to 2a over a plus 1. Now it tells me in the question that g of a equals negative 2. So what I have is this, in fact, equals negative 2. What I now have is an equation that I can solve. So now this goes back to solving equations, okay? So this skill now is solving equations. So here we go. If we have 2a over, actually I'm going to use a different colour pen. If we have 2a over a plus 1 equals negative 2, how do I start this? I'm going to multiply both sides by the denominator, which is a plus 1. If I multiply both sides by a plus 1, the reason I do this, and then you'll see in a previous video that I've done, okay, is because this is going to cancel it out. Okay, and whatever I do to one side of the equation, I have to do the other because I have to balance them, yeah? So then this becomes 2a equals minus 2 lots of a plus 1. That's our denominator. Now, some of the biggest mistakes people make here is when they multiply by this denominator, they don't put brackets. You can put brackets wherever you want, but remember that a plus 1 is one thing. Okay? So, what we're going to have now is 2a equals, I need to expand my brackets, negative 2 times a is negative 2a, negative 2 times 1 is negative 2. I'm now going to add 2a to both sides. Remember the reason being, again, these are going to cancel to get 0. I'm going to get 4a equals negative 2. How do I now find A.
Just divide the 4.
Yeah, divide both sides by 4. Because remember, 4A divided by 4 just leaves me A. And then minus 2 divided by 4 is minus 2 over 4. We're going to simplify that to negative a half. Or some of us might be comfortable with writing minus 0.5. Okay, so there we go. This is how we solve part C. We substitute in the value of A into our function. We then put it equal to what it says, and then we just solve. Again, this is just solving linear equations. So here we go. So express the inverse function f to the minus 1. So we want the inverse function of f. The first thing I'm going to do is I'm going to write what f of x is. F of x equals a half x plus 4. Okay? F of x equals a half x plus 4. So if I want the inverse of this, what I'm going to do is I'm going to say, okay, f of x equals a half x plus 4. I'm going to say y equals a half x plus 4. And to find the inverse of f of x, I'm going to rearrange to get x equals. Okay, so this is what finding the inverse is. We're rearranging to get x equals. So how do I rearrange to get x equals? Again, there'll be another video on YouTube, okay, with rearranging equations. So this is where this skill links in. First thing I'm going to do is take away 4 from both sides. Okay, so I'm going to get y minus 4 equals a half x. After I take away 4 from both sides, if I've got a half x equals this, what do I now need to do to both sides to get x equals? I'm going to multiply by 2. Okay, so remember I took away 4 from both sides here, because remember this is going to cancel to give me 0. If I now multiply both sides by 2, a half x times 2 is 1. So then I'm going to get 2 lots of y minus 4 equals x. Or you might want to expand that and do 2y plus 8 equals x. Now the final step that I'm going to do is I'm going to write this down, f of x minus 1, and wherever it says y, I now put x, okay? So now my inverse is 2x plus 8, okay? Minus 8, oh my golly. What a silly mistake. Okay, so 2x minus 8. This is the inverse function. Now what does the inverse function mean? Here we go. I'm going to take us back to probably primary year 7. Okay, and here I want you to look at this, okay, and this is where functions come from. Do you remember in the questions we used to do, it'd be like, right, x, what's the first thing you're going to do to it? Is you're going to divide it by 2. Then you're going to add 4. And this is going to give you your answer, y. Okay? And then do you remember it said, find the output when x is 4. So we'd be like, okay, when x is 4, what do? We divide that by 2, we get 2. And then we add 4, we get 6. The output is 6, okay? And then do you remember sometimes there'd always be like a part B question, and it'd say, find the input when the output is 10. So imagine, if we knew the answer was 10, going backwards, what do? We minus 4, then times 2. This is what we've done here. We do y, we minus 4, and then we times 2. We're writing an equation, essentially, for how to go backwards. This is what we're doing. So if we did do 10 minus 4 is 6 times 2, that means that we should have put in 12. We can check we're right. Let's see. Pretend x is 12. If we divide that by 2, what do we get? 6. 6 plus 4, 10. I know I'm right. And do you remember sometimes it'd say, find an expression for the function machine. Do you remember? So if we were to find an expression for the function machine, if I start at x, I'm going to get x divided by 2. I could write x divided by 2, but I know as a mathematician, I'm going to write x over 2. It's the same thing. X divided by 2 is the same as x over 2. Okay? And then what do? We add 4 plus 4. This is what my function machine is, and my output is y. So x divided by 2 plus 4 equals y. Everyone happy with that? Going backwards, imagine I started at y. If I start at y, okay, what do I do to y? I take away 4. Yes? Okay? And then I times that whole thing by 2. So this is where I put brackets to make sure I know I'm timing that whole thing by 2. And this gives me x. And then what I do, of course, I don't write bracket times 2, do I? I could either write 2 lots of y minus 4 equals x. This is in factorised form because I've taken out a factor. Or I could expand and simplify to get 2y minus 8 equals x. Okay? So why I then put x in at the end is because it says write the inverse as a function of x. So then I substitute x in wherever there's a y. Yeah? So this is functions, an 8-mark question. There's a lot going on there and a lot of understanding. Okay? Okay, so this question is a really nice question because we get to speak about the domain of f and the domain of g. Now, what's good about this is we're getting 2 key examples here. Okay, as we can see, f of x is 1 over x plus 2. Here we have a fraction. Everyone happy we have a fraction?
Yes.
Now, what do we know about fractions? What can the denominator never equal? It's mathematically impossible for the denominator to equal something. 0, absolutely. So we're now saying x plus 2 can never equal 0. And if you put that into your calculator, if you put 1 over 0, you're going to get a math error, aren't you? Because remember, we can't divide by nothing. It doesn't make any sense. So we're saying x plus 2 cannot equal 0. If x plus 2 is not allowed to equal 0, what can x not equal? Negative 2. So here we go. So for f of x, state which value of x cannot be included in the domain of f. It means x cannot equal negative 2. Because if x did equal negative 2, this would make the denominator 0. And that is not allowed. So the domain actually means what values of x can we input. In our case, we could put in any value apart from minus 2. So, state which values of x cannot be included in the domain of g. Now, if we have a look at g, okay, we have a square root. Does anyone know anything about square roots? Inside the square root, what can we not have inside a square root? Okay, so some people are saying we can't have 8 inside there. We can. Root 8. That works well. If I put that into my calculator, I'm going to get 2 root 2. That's fine. It just means I've left it in third form. There is definitely a set of numbers that I cannot have in a square root though. So what? Yeah, I can have the square root of 0. The square root of nothing is nothing. Negative numbers. I cannot square root a negative number. It's physically impossible. If you think about it, what is a square number? Okay? A square number. Do you know 2 numbers multiplied by each other? Okay? Remember, a number squared. So if we think, everyone happy that 5 squared is 5 times 5? What do we get? 25. Okay? How about minus 5 squared? That's minus 5 times minus 5. I still get 25. When I square a number, I get a positive. Okay? Because it's a number times by itself. Right? I cannot square root a negative number. It's impossible. If you put it into your calculator, some calculators might say math error. And some calculators might come up with a little I. That's an imaginary number. That is not something we're going to be talking about today. Okay, so this means that x minus 1, if it can't be negative, what can it be? This means it has to be greater than or equal to 0. It has to be greater than or equal to 0. X minus 1 has to be positive. Has to be 0 or bigger. Okay? So, then what does x have to equal? Greater than or equal to 1. So now that we know that the only values we will accept is when x is greater than or equal to 1, let's read the question properly. It says, state which values of x cannot be included. So x, therefore, cannot be less than 1. If x is less than 1, okay, this means the domain, okay, it can't be included because this means we'll get a negative number. Like, let's have a look. A number x less than 1, what do we get? 0.5? Is that less than 1? If I put 0.5 minus 1, what do I get? Negative 0.5. Someone try and square root negative 0.5 for me. Someone try and square root that. See what we get. Math error, of course, because we cannot square root a negative number. Okay, so there is the domain. Now we have part B and C, which are nice and simple. Okay, very quickly, we're going to go through B. So we're going to do f of g of 10. So remember, that's f of g of 10. Okay, so what is g of 10? G of 10 equals the square root of 10 minus 1, which is root 9, which equals 3. Okay, now, then f of 3 equals 1 over 3 plus 2, which equals a fifth, which is 0.2, or a fifth, either one, yeah? Nice and simple. Okay, that was really quick, and everyone in the class has got that right, which is perfect. It now says, express the inverse function g to the minus 1. Okay, so we know g of x equals the square root of x minus 1. So what's first step? Y, imagine, okay, this is going to make your life easier, right? Imagine this is a function machine, okay? So what happened? We had g of x. Tell me, what did we do to x first? Sorry, not g of x. Oh my golly. Okay, if we had x, what was the first thing we did to x? We took away 1. Brilliant. Okay. Then, after we took away 1, what did we do to x? We square rooted x minus 1. And this gave us our function g of x, isn't it? So if we want to find the inverse, imagine going backwards. If we went backwards, instead of square rooting, we'd do the inverse, which is, so we'd square it, then we would add 1. Okay, so the inverse is x squared plus 1. Because we square it and then we add 1.
Yeah, but then wouldn't x be
Tell me. So I'm going to show you another way.
wouldn't x be 0.2?
So if we let y equal the square root of x minus 1. Okay, I look at this. I have a square root here. This is basically saying y equals x minus 1 to the power of a half. So I'm going to square both sides. So I get y squared equals x minus 1. How do I now get x on its own? I'm going to add 1 to both sides. So y squared plus 1 equals x. Now I've rearranged this. It wants it in the form g minus 1 of x. So it wants x in the function. So this is why I write x squared plus 1. So g inverse of x equals x squared plus 1. So I'm changing y to x because it has an x in the bracket. And it wants it in terms of x. But it's easier. Some people change it where they say, right, some people teach it where they say, right, change all your x's to y's and then rearrange to get y equals. However, it's just if we understand this process to begin with, we'll get used to it. There's many different ways and all of them are correct. Okay, here is question 3. Now, a lot of confusion I'm seeing in the classroom. Okay, f dot x. This is the same as writing f of x. It's just a different way of writing it. Just like BRB is the same as B right back. Okay, just a different way of writing this. Okay, so f of 3, nice and simple. We're going to do f of 3 equals 2 lots of 3 minus 1. 6 minus 1, 5. F of G of 6. So this is saying F of G of 6. We're going to do G of 6 first. Okay? Which is 3 over x. Our x is 6. 3 over 6 is a half. So this means I now do F of a half, which is 2 lots of a half minus 1. 2 times a half is 1, minus 1 is 0. Okay. Part B says express the function f of minus 1 in the form f of minus 1. It literally is just saying f of minus 1x, which is what we've been doing. So if we know y equals 2x minus 1, I'm going to rearrange this. Y plus 1 equals 2x. Y plus 1 divided by 2 equals x. So that means the inverse function of f with x is x plus 1 divided by 2. It is y plus 1, however, because it wants it in terms of x, everywhere there's a y, I now put an x. Okay? Now, the next part says express the composite function g of f of x. So this is g of f of x. Now, some of you have been looking at me like, Miss, I've never even seen this in my life. I don't know how to do this. Guys, do you know how to do g of f of 2? Yeah. Do the same thing, but wherever you would put 2, put x. Simple. So, g of f of x. So, what is f of x? F of x equals 2x minus 1. So now, g of f of x means g of 2x minus 1. So this means wherever there's an x in g, we can see here, what am I going to substitute? X minus 1. So I actually get 3 over 2x minus 1. Okay? It then says which value of x must be excluded from the domain. What do we know about the domain of a fraction? The denominator cannot equal 0. So that means 2x minus 1 cannot equal 0. So 2x cannot equal 1. X cannot equal a half. So which value of x must be excluded from the domain of g of f? Okay, and that's because we did g of f here. It is x cannot equal a half. So x equals a half has to be excluded. Okay, well done. Okay, so a nice simple question bringing all these skills together. So find f of 8. So everywhere there is an x, we're going to substitute in 8 minus 6 divided by 2, which is 2 over 2, which equals 1. So nice and simple for the first part. For the second part, it says express the inverse function f to the minus 1 in the form f to the minus 1 of x. So what we're going to say is let y equal x minus 6 divided by 2. To find the inverse, now remember we could do this 2 ways. We can either think of it as a function machine, or we can just do rearranging equations. Ideally, we want to understand what's happening, and we're going to do rearranging equations. So we might have to do some extra work on that, and that's okay. So, first thing I'm going to do is multiply both sides by 2. So I'm going to get 2y equals x minus 6, because I want to rearrange to get x equals. Then, what's the next thing I have to do to get x on its own? I need to add 6 to both sides. Absolutely correct. So I'm now going to have 2y plus 6 equals x. And then for the final stage, remember it said f inverse x. So we want this in terms of x. So what we just write is 2x plus 6. However, if you did in the exam leave it as 2y plus 6 here, you would still get the 2 marks because it does this thing called OE, or equivalent. Okay, so you would still get those 2 marks. Right, so part C. We now have a function g of x, okay? And g of x equals the square root of x minus 4. Which values of x cannot be included in a domain of g? Now, what do we know about square roots? Inside, we cannot have a negative value. So we know that x minus 4 has to be positive. It has to be greater than or equal to 0. This is what it has to be. So that means x has to be greater than or equal to 4. However, in the question, it says of x cannot be included. If we know x has to be greater than or equal to 4, so what can't be included is it can't be included when x is less than 4. Okay? Because if you think about it, x is less than 4. Let's put 3. 3 is less than 4, right? So let's say x is 3. 3 minus 4 is minus 1. This gives us a negative. Okay? We can't have square root for negative. So this is how we do it. But be careful of the word in here and make sure you really understand what's going on. Oh, wait there, I've clicked something. Here we go. Right, so express the function g of f in the form g of f of x. So we're all happy that f of x equals x minus 6 over 2. Okay? So g of f of x, if f of x equals that, we're actually saying we want g of x minus 6 over 2, because that's f of x. So everywhere there is an x in g, we are going to write this. So we're going to have x minus 6 over 2 in brackets minus 4. And all we've done here is our regular substitution. Okay? So from here, people always forget, you know. Anyone remember being in year 4 or year 5? Yes. Yeah? Probably learnt to add or subtract fractions. Now forget about this algebra for a second. Think about it. If you had half minus 3, okay? If you had a half minus 3, and you were to show how you do that, what is the first thing you would do when you add or take away fractions? So yeah, you're completely right. First of all, we turn 3 into a fraction. 3 whole ones is 3 over 1. And then we would make the denominators the same. In our case, it'd be easier to multiply 3 over 1 by 2 on the numerator and denominator. So we're going to get half minus 6 over 2. Now the denominators are the same. We can subtract or add the numerators. It's the exact same principle. Okay, so here we have a fraction, and this is what we love about algebra. And when we do algebraic fractions, you know, the grade 8, 9 topics, okay, you'll see it's all about going back to basics. Think about all the basic knowledge you know. When you add or take away fractions, what is the most important rule? Denominators need to be the same. So if I've got x minus 6 over 2 minus 4 over 1, what do I need to multiply 4 over 1 by to get a denominator? 2, absolutely. I'm going to multiply it over by 2 and 2, because whatever we do, the numerator, we multiply the same as the denominator, right? So I'm going to get x minus 6 over 2 minus 8 over 2. This then simplifies to x minus 6 minus 8 all over 2. Minus 6 minus 8 is in fact minus 14 over 2. So now the final answer is the square root, because I know this is all in a square root, but I haven't written it down because I've been a little bit lazy. So we're going to have x minus 14 over 2 is the simplified version of x minus 6 over 2 minus 4. And this is the composite function of g of f of x. And that is the final answer, because we can't simplify that anymore. If you wanted to, some people might write this x over 2 minus 7, because 14 over 2 is 7. Yeah? However, you can leave it like this. Either way is correct. Okay? Okay, just a few hints for this question. We should all be able to substitute here. Domain, remember if we have a fraction, and you can see here we have a fraction, remember the denominator, cannot equal 0. And then find f of x. I don't know why some of us are getting confused. However, we know that f of x, wrong question. For part C, we know that f of x equals x over x minus 1. So now if we do f of x, we're essentially saying f of x over x minus 1. So everywhere we see an x, here and here. So really what's going to happen is we're going to have this divided by our x minus wait there, I don't know what happened, minus 1. So now, here we're going to have x over x minus 1 divided by x minus 1. Now you need to simplify, rearrange, etc., etc. Okay? So, some people still a little bit confused how I got to this stage. Tell me, what would you do if you had f of 2? Okay, so you'd have f of 2 equals 2 over 2 minus 1, yeah? Once you worked that out, what would you then do?
Take whatever that is.
Yeah.
And then you put it in the f again.
Yeah, so we take whatever this is and put it in the f again. Brilliant. Imagine 2 over 2 minus 1. You didn't work out. You left it as that. What you're then doing, if you put this in the f again, f of 2 over 2 minus 1, that's going to equal 2 over 2 minus 1 over 2 over 2 minus 1 minus 1. Because the original is x over x minus 1. F of x is x over x minus 1. So everywhere we see an x, we substitute in x over x minus 1. Because if you think about the function, essentially what we're saying is whatever is in the bracket, yeah? Remember, this is bracket over bracket minus 1. That's our original function. If we go back to the question, if you have a look here, okay, it's basically saying whatever's in this bracket goes here, here. Yeah? So, what we have is, in our case, when we're doing f of x, we know f of x is x minus 1. So if we now have to do f of x, wherever the x minus 1 is, we now substitute where the previous x was. Now you need to simplify this, however. But this is just stage 1, is being able to substitute this in. You're going to get 1 mark for. So just to clarify, f of 2 was an example then. I'm not going to solve it. Like x over x minus 1, we can't solve that anymore. If we had a 2, we'd be able to. Okay, so for this question, we're just going to look specifically at part C, because when we look at our function, got some very smart people in the room, they've noticed, if we're going to rearrange this, what do we notice? There are 2 x's. We want to rearrange to get x, okay? So let's go through the steps, and let's see how far you got and how intelligent you are. Step 1, did you multiply both sides by x minus 1? If you did, fantastic first move, okay? The second step, did you expand correctly? What is y times x? Yeah, xy. What is y times negative 1? Minus y equals 2x. Okay, now I've heard some crazy theories running around. Some people saying divide by 2. I'm not sure why. Okay. And then someone's saying, no, we can't divide by 2 because we've still got x's on either side. What do you think would be a good next step, an intelligent next step?
X, y,
Yeah, let's make sure that all the x's are just on one side of the equation. So to do that, I'm going to take away x, y from both sides. Okay, that way they cancel, yeah? And I'm not changing the quantity. So minus y equals 2x minus xy. Okay, fantastic step there. Honestly, very intellectual. However, what can I do now? Absolutely. If I want 1x, let's just factorise out x, okay? So minus y equals x bracket 2 minus y. Do I now have 1x?
Yes.
Hallelujah. How do I now get it on its own?
Let's just move the 2y to underline.
Yeah, we're not going to move it. Yeah, we're going to divide both sides by 2 minus y. Okay, we really need to understand what we're doing. Where, why, how, who, that kind of stuff. So we're going to get minus y over 2 minus y equals x. Because we divided both sides by 2 minus y. I have now simplified this. Rearranged. For some people, okay, you might have something slightly different depending on which way you did it. For example, okay, I'm just going to stop us here. Side note, what if you added y to both sides, okay? What if we rearranged it so we got xy minus 2x equals y? So right here I added y to both sides and I put the 2x on this side. Do we understand? Yeah? It's just another scenario, for example. What we find is we have x bracket y minus 2 equals y. So x equals y minus 2. Okay? So both of these equations are completely correct. If you notice, for this equation, everything here is timed by -1. So either or. So you might be thinking, well, hold on a minute. You're watching this and you're like, I did not get negative y. You might have got y over y minus 2. Both correct. Okay? We're going to explain more into that later. But right now, as long as we're happy doing this, that's perfect. It's quite common in the GCSE that they always have multiple x's. It's either this, where you have multiple x's and you have to factorise, or they give you a quadratic. And when we get a quadratic, we have to complete the square to then get x on its own. It's very similar to the one before, so you should be fine going through this. And make sure that you know that the domain is our input, okay? Question 8. Again, very similar. However, for part C, when it says solve the equation g of x equals 1.2, all we're going to do is write x over x minus 1 equals 1.2, multiply both sides by x minus 1, expand, solve, simplify. And again, when we're doing the inverse, remember we have two x's, so we are going to have to do a factor. I'm not sure what this question says here, but you can always go onto the website and download this PDF and then find out what it is. Okay, question 9, again, very similar, and this time for part B, what you're going to be doing is solving the equations h of g of x equals h of x. So we are going to have a solving a quadratic equation. So let's just see how that quickly looks. So we're going to have g of x, we know is 2 plus x. So h of g of x is h of 2 plus x, which equals 2 plus x all squared. Now if I expand that, 2 plus x, I'm going to have x squared plus 4 plus 2x plus 2x, which is plus 4x. This is going to equal h of x, which we know is x squared. So if I take away x squared from both sides, that's going to cancel, get 4x plus 4 equals 0, 4x equals -4, therefore x equals -1. Nice and simple. Oh, so this video offers some fantastic starter questions into functions. However, there is still another type where they could say f of x equals x squared plus 4x plus 7, for example. And they want you to find the inverse function of this. Now, this is typical in the IGCSE, and I'm going to do some more examples on this. So now let's just do one. Now, if we need to solve this, we want to rearrange this to get x equals, essentially. When we have a quadratic, the best way to do this is by completing the square. So I will put up a video about completing the square. However, for now, a brief intro. So x plus 2 squared, okay? So I'm doing half the coefficient of 4x, because I know, forgetting about the 7, that x plus 2 squared is actually going to be x plus 2, x plus 2. So I'm going to have x squared plus 4x plus 4, okay? So I know that's what's happening over here. However, I have plus 7, so what do I need to do to x plus 2 squared? Again, from 4 to 7, I need to add 3. This is in completed the square form because I have a square number plus a constant, which is fun. Okay. I have another video that discusses this in greater detail. So for now, this is what we'll do. We're then going to say y equals x plus 2 squared plus 3. And then we start again rearranging. So we're going to take away 3 from both sides. Y minus 3 equals x plus 2 all squared. We're going to square root both sides. So if I square root square, that's going to cancel. And I'm going to square root y minus 3. Now remember, the square root's going to give me a plus or minus. Okay? Once I've done that, I'm just going to rewrite this slightly different. I'm going to get x plus 2 equals plus or minus the square root of y minus 3. Okay, because remember that's going to cancel that. Now, now to get something done, I'm going to take away 2 from both sides. So minus 2 plus or minus the square root of y minus 3. So the final answer is the inverse function of x equals minus 2 plus or minus the square root of x minus 3. That is our final answer. And this is just to let you know that there will be another video coming out explaining when we have more of these types of questions. Okay? Just a little sneak peek of what's coming. So make sure you complete the questions. Have a look on the website for the answers. And yeah, good luck. Hope you enjoyed the video.